Hello, everyone, and we will be starting our last week of instruction this week, and we'll be ending with two lessons. The 8.2a lesson, which is just an introduction to the types of visual graphs we'll have when plotting data, and our second lesson is going to be on something that we call the box and whisker plot. So I'm excited to teach that material to you guys, and let's just get started. So the first portion of this lesson, we were supposed to create a survey and kind of conduct an experiment with the class. I'm going to bypass all of that, and I'm just going to talk about some definitions right now. So, and you may be familiar with these, but I'm going to go ahead and remind you of these definitions. Okay, so a histogram is a type of graph that displays quantitative data. Okay. Now you might say, is this a bar graph? Yeah, this is a bar graph, but most importantly, it measures the quantity of a certain point. And remember that the bars touch each other because they represent continuous data. The bars touch each other as they represent continuous data, right? Continuous data meaning that every single point matters, and there is data for all of the categories, right? Or all of the quantities, all of the amounts, which means like, um, you know, how many burgers does Mr. Quo eat in a month? One, two, three, four, five. You would have all of the quantities listed out, and you would have a certain amount of each quantity. So it's continuous. Each quantity is represented. Okay. A bar graph is similar to a histogram, and they do use these vertical bars, but it's a type of graph that represents categorical data. Represents categorical data. So categorical data class is basically data that when you display um, your x-axis, it's not just numbers like the histogram used to be, because the histogram is quantitative. A bar graph is categorical, where the x-axis will now have categories like, what's your favorite color? Red, blue, green, or yellow. And then it will just go up. The bar graph will go up according to the category, right? So it can look something like this, but on the bottom it will say red, blue, and it will have categories on the x-axis, okay, instead of numbers. Numbers, then that would be a histogram. For a bar graph, technically the bars should not touch because you have a lot of space. You should make your categories spaced out. Okay, it's very, very similar though overall to the histogram. And then finally, we have a dot plot, which is a graphical display of numbers. It's just a visual, a graphical display of numbers. Okay, dot plots are used often, and they're used to show growth. So like sometimes you'll see a dot plot go like this, and it will look maybe something like that, right? And you can see how it's just representing the dots. Now this is kind of like overall growth over time, but sometimes dot plots can also look like this, just like dots. Right? So it's just a display of numbers. Okay, so we're going to dive into three keywords that you may have heard before. These are very, very important, and these definitely help you determine the measure of central tendency for your numbers, right? So whenever we accumulate statistics class, we always want to write certain characteristics about our group, right? We've heard of something called the mean, which is basically the average, median, which is the number in the middle of the data. When the data is ordered from least to greatest, it's a number directly in the middle. And then the mode is the number or the value that occurs the most frequently. Okay, so I'm going to write these down again one more time. The mean is the average of all the numbers, of all the data. We calculate this probably the most. The median is going to be the number directly in the middle. Directly in the middle of the data. And then the mode is the data value that occurs the most frequently. Okay, so now a couple things I want to reiterate. Okay, the mean is pretty straightforward. The mean is basically just the sum divided by the amount of data points. Right? That's how you find the average of something. You take the total value, which is the sum, and divide by the amount of how many numbers there are. The median is the number directly in the middle. But what happens if you have an even amount of numbers? For example, what happens if you have 1, 2, 3, 4, 5, and 6? Do we see how there is no number directly in the middle? So in this case, in this rare case, where you have an even amount, you then have to average the two, and your median is actually the average, the two numbers in the middle, I should say. Your median is the average of the two numbers in the middle, and in this case, your median is 3.5. I know that's weird because we don't even have a number that's 3.5, but that's how you calculate the median if you have an even amount of numbers. Okay, and then finally, for the mode, the number that occurs the most frequently, if in this situation the numbers were 1, 2, 3, 4, 5, and 6, there actually is no mode because all of the numbers occur exactly at the same frequency. Okay, so if you just have one number for all of the numbers, there is no mode, and that's totally fine, right? If no number in the list is repeated, then there is no mode. Okay, if no value is repeated, there is no mode. Okay. All right, and that's basically how you calculate the three pieces of information for data points. Let's go ahead and just practice calculating the mean, the median, and the mode. Okay, so I'm going to give you a few numbers. I'm just going to create numbers right now. Let's do that. Okay, so how about I just give you random numbers? So I'm going to go with 3, 9, 20, 12, 2, 21, 34, 24. Okay, so first of all, class, what do you notice about the numbers that I've written down? If you said that the numbers were not ordered from least to greatest, then that would be correct. Okay. The first thing I would ever do whenever I get a set of data points like this, class, is I want you to first identify how many total numbers there are. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 numbers. What I'm now going to do is I'm going to, one, order them from least to greatest. So I'm going to scan. I'm going to put a dot next to the numbers that I notice. So 2 is my first number. 3 is my second number. We have 9. Then we have 12. Then we have 20, 21, 24, then 34. Okay. Now, once I'm done ordering it from least to greatest, I would recommend that you recount all your numbers just to make sure that we have the same amount. 2, 3, 4, 5, 6, 7, 8. So we have 8. Nice. Okay. So the three things that we want to calculate, and I'll write this down, are mean, median, and the mode. Now, I should have realized this, but we actually don't have a repeating number. So I immediately know that there is no mode. Okay, so now I'm going to calculate the mean. So on my calculator, I'm going to then just take all the numbers and go 2 plus 3 plus 9 plus 12 plus 20 plus 20, 5, but I should have added 21, plus 24, plus 34. I'm scared, so I'm going to redo that one more time. 125. Let's do that. 5, this is 21, 26, 41, so that's 67, and then 67 plus 58. It's 125. Okay, good. So 125 is the total sum, but now I have to take 125 and I divide it by the amount of numbers. The amount of numbers. So the amount of numbers would be 8. So it's 125 divided by 8, which is not going to be clean, but I get 15.625, which I'm going to round to 15.6. Okay, so that's the mean. The last thing we have to do, class, is the median. And since we have an even amount, right, that means there's 4 on the left side, 4 on the right side. That means your median is going to be directly in the middle of these two numbers. It's the average of these two numbers. So what's the number directly in the middle of 12 and 20? Well, it's not a whole number, but it's, oh, actually it is. I can't believe I messed that up. 12 plus 20 is 32, and 32 divided by 2 is 16. And that is how you calculate mean, median, and mode, class. That was a very quick example, but I hope that all made sense. Okay, study these vocab words. Remember, class, a histogram is a bar graph that displays quantitative data. So there's quantities, there's amounts on the bottom. A bar graph is similar, except it has categories on the bottom. And then a dot plot is just a regular plot that has dots regarding whatever amount they have. And they don't use bar graphs. Okay. Next, we're going to talk about the box and whisker plot. So it's going to be very similar to all this calculation. So stay tuned for that.